In the previous video, we have already seen this. So in this video, I'm going to explain this first, and then use these two to justify these two. So let's look at this one first. So going back to our diagram, to understand where this thing comes from, we are going to work out this length. Well, this length here is equal to this length, and then we set these two lengths to be the same, and then that will eventually lead us to this thing here. So let's try and find this length first. So from here to here, to find this length, well, let's just draw a straight line down here. So so this will form a right angle triangle right here. So that will form a right angle triangle. So let's call this length here Z. So what is this Z? Because this Z is the same as this length here. So let's work out Z. So Z equals, well, looking at this, so we know we need cos. So cos, the combination cos this angle here will be x plus y. So cos x plus y equals this length, which is Z, divided by this length here, which is 1. So so from here to here turns out to be cos x plus y, which is the same as this. So what we know so far is that this is cos x plus y from here to here. Okay, so this length now, let's call this length Z, and then looking at this triangle here, so we know we're going to need sine. So sine the angle, which is y, that equals Z divided by sine x. Z divided by sine x. So Z equals sine y sine y sine x equals Z. So this length here will be, that length there will be, this length here will be sine y sine y x, sine y sine x, sine x. So that's what we know so far. So now to get this length, we would use this triangle here. So that's our right angle triangle here. So we want to know this length. Let's just call it Z. So we know we need cos. So cos the angle. So hang on, let me think. So cos the angle here, which is y, that equals Z over cos. So Z over cos x. So we want Z on its own, so times both sides by this. So that would be cos y cos x equals Z. So this length here, so this whole length here is cos y cos x. So let me clean this up. Okay, so now to understand where this comes from, we are going to set this length to be the same as this length. So that would be, so this length here would be, so that length there would be cos x plus y, which is from here to here, plus this length here, which is plus sine y sine x, equals this length here, which would be cos y cos x. So now we want to get this block on its own. So what you do is you take away this block from both sides. So that would be cos x plus y equals this thing, take away this thing. So that would be cos y cos x, take away sine y sine x, which is the same as this thing here, because this thing is the same as this thing, and this thing is the same as this thing, and then this thing is the same as this thing. So now now we know that this is true. So far in the previous video we've seen this, and I've just shown this. So now we can use these two to justify these two. But before we can do that, I need to explain, I need to remind you, because you should already know this. Cos is an even function. Sine is an odd function. What that means is, so this is just a reminder, an even function is when you apply this transformation, you actually flip it along the y-axis. So if you look at f of x equals x squared, if you flip it along the y-axis, it will look exactly the same as its original self. So when you apply this transformation, it looks the same as its original self. So if I were to ask you to find, let's say, f of negative 3 for this function, because we know it's an even function, don't bother with this negative thing, just find f of 3. So what that means is, when I ask you to find f of negative 3, which would take you to 9, don't bother with the negative, just concentrate on the positive version. It would be simpler, it would take you to the same place, 9. So cos graph is when you flip it, when you apply this transformation, you flip it along the y-axis, it's symmetrical, it's an even function. So when I ask you to find cos of, let's say, a negative number, don't bother with this negative number, just concentrate on finding cos of a positive number. So cos of negative 1's here, don't bother with the negative 1, just find cos of 1. It would take you to the same place. It would take you to the same place. So if you know an even function, if you know a function is even, don't bother with the negative, just concentrate on the positive. Well, cos is an even function, so ignore the negative. So cos of a negative number would be the same as cos of the positive version. So bear this in mind. We will need this, and the same goes with sine. When you a sine graph looks like this. When you apply this transformation, you flip it. So you reflect it along the y-axis. So it looks like this. Let me extend it to the negative. Let me extend it. So now it looks like this. When you apply this transformation, it would be the same as the original function, but turned upside down. So that's this bit here. You turn it upside down, it would be the same thing. So what I'm saying is that if I were to ask you to find sine of negative 1, don't bother with this negative. Just find a normal sine and then stick a negative in front of it. Okay, so bear this in mind. We're going to make use of it now. So here I'm going to try and use this, which we've already seen in the previous video. I'm going to try and get from here to here. So whenever you have one angle plus another angle, well, this angle goes into here, and then it goes into here. So whenever you have one angle plus another angle, I can just simply put it into here. I can put it into here, and then this second angle I can simply put it into here. I can simply put it into here. So this second angle I can simply put it into here. I can simply put it into here. So for me to understand this, I'm going to do this. I'm going to have one angle plus, which is the same as this up here, but then I'm going to have a negative angle in here, negative y. So this thing here now looks the same as this, but the thing is, I'm going to use this to somehow later on migrate to over here. So hang on, let me clean this up. So I'm going to have one angle, I'm going to have one angle plus another angle. So that I'm going to put this as x and this as negative y. So that means this will be x, because I'm making use of this. This is exactly the same as this. So if this is x, then this must also be x. If this angle here is negative y, then this would be negative y, and then this would be negative y. So now cos, remember cos is an even function, so we ignore the negative and it just becomes this. You see this block here, even though is a negative, is the same because cos is an even function. This is the same, as it stays the same. And then see this sine here, sine is an odd function. So whenever you see this, whenever you sine a negative angle, then just imagine as -1 times a positive version, because it's an odd function, just like I explained earlier. So imagine, hang on, let me clean this up. So imagine this, hang on, imagine this block here as the combination of these two blocks. So now we can drag this -1 out here, so this positive becomes a negative. So you can see it gives you this. So that's this thing done. Hang on. That's this thing done. And now for the other one. So now for the last one, we need to justify this. So start out with this, which we've already explained at the beginning of the video. So whenever you have one angle plus another angle, is you making use of this. So whenever you have one angle plus another angle, this thing here is the same as this. So now to understand this, I'm going to put a negative angle in here. So this would be -y, this would be x. So that would mean this is x, this is x, and this would mean this is y, -y, -y. So -y, -y. So now looking at this, remember cos is an even function. That means I can just ignore this negative and I can just consider this block as being the positive version. From rather than negative angle, just consider as a positive angle. And then this sine here, I can imagine it as the combination of these two blocks, -1 times sine of the positive version of this negative angle. So that will then take us to here. So now let's drag this negative out here. So this negative becomes a positive. So therefore it becomes this. So now I've just shown all four. Okay.